So this is a really easy example in EES, an easy example in EES. We're just going to solve some really basic equations. Getting started sometimes is half the battle. So the first thing we have to do, we don't want that, whatever, is open either the desktop app of Citrix, which I think works better than the web app. So there's Citrix. Oftentimes you get this warning. I don't know what that's about, but we'll just hit OK. This is new for the pandemic. These are physical machines that are over at 1410 Engineering Drive, kind of by the fountain on engineering campus. It just says don't overload those machines by doing research on them. It's just for you guys to do for your classwork. So you say, okay, this is all the software you can run on EES or on Citrix. A lot of you guys have used SolidWorks already, but we're going to be today working in EES. So I select EES, and sometimes that takes a little bit. So I can pause the recording. Okay, so there we go. Then this pops up. You can adjust some stuff here. Professor Klein, Sandy Klein, is the professor that wrote EES. And let's see, anything else interesting here? No, not really. So we'll continue there. Okay, so the first window that pops up is your equations window. All right. And so this is just the example that I did in class. I tend to make mine kind of tall and skinny because I don't write really long equations. I like short and easy equations. So what we'll do is I always like to put a heading on it in quotes. Easy example for ME201. And then I'm going to write x plus 3 equals y. All right, and then, x plus y equals 3. And then I'll type y equals z minus 4. That was the second equation. And then the third equation is z equals x squared. That's how you make the squared symbol, minus 3. All right. Okay, so some stylistic or practical things here. I'm going to make this window just a little bit smaller so you guys can see the whole thing. I'm just worried that I might not be recording the whole screen. There we go. And actually what I might do too, sorry to waste your time with this, I'm going to go to Options, Preferences, and then down here for Display, I'm going to make the font really big, right? So now I have nice big font there, so it's easy for you guys to see. First thing you do, all right, the very first thing you should do, I've got 3 equations. I'm going to type save, or click the save icon. Where do you save this? All right, don't save this on this PC. This PC is a machine physically at 1410 Engineering Drive. You have no idea what machine this is, and you don't have access to it. So what you should do is scroll down here and go to Box, not the local disk, not the desktop. I know people love storing stuff on desktop or documents or some crazy place like that. Go to Box. Hopefully you have Kumo enabled. I'm going to go to ME201. Now you probably don't have to go this deep, but we go to ME201. It's a little pokey, right, because this is all running remotely. This is fall 2020. And lectures. This is really slow, and then we're in week 6. And I'm going to call this something, first simple ease example frosh. All right, so save that. So now I know it is saved. Save your work. I happen to have learned the hard way that all those machines, right, these are physical actual computers that are running on a shelf over in 1410 Engineering Drive, that they all reboot at 5:15 on weekday mornings. And you can guess how I learned this. All right, so it tends to be a little slow. Now notice down in the lower corner there it said uploading to Box, right? So I saved it not on that machine, but I saved it to Box. All right, so I saved. Now let's grayed out. I'm going to check 3 equations and 3 variables. That's good. I know from math that I can solve a system of 3 equations and 3 variables. Okay, and I always do this. I check units. right? We haven't talked about units yet, at least not in the examples, but there are no unit problems. So then I can finally, I've gone save, check units, and finally this little calculator button here, or I can hit the F2 on a Windows machine. I'll run this, okay? And it tells me a little bit about it. It took 16 milliseconds to run this, all right? Not a terribly complicated system. I click OK. And sure enough, I got the same answers that I did in the previous attempt at this. 2.702, 0.2984, and then 4.298, right? But remember, since this is quadratic, right, shouldn't I have two potential options for x, right? Because it's x squared, so there could be two solutions for this. The way this works, remember, is with Newton's method, where I just make a guess, and then I go up and I shoot a tangent line down to the intercept, and then I make my second guess near there, right? And it keeps doing that, and this happens to be the closest to the first guess, right? Well, I can change my guess, and I'm going to make my guess. Let's see. I'll go back to my equations window. This is a very, very important button here, variable info. All right, so the initial guess, always by default, is just 1, right? And I'm going to make my guess for x to be -1, okay? And then what happens if I solve this again? It took 15 milliseconds that time. Ooh, and I get a different value. This is very important to know. This is a machine. The machine doesn't know what you want. The machine doesn't know if -3.7 makes sense or positive 2 point something makes sense. It doesn't know. So your guess values are very, very important. Where do you get at your guess values? Right up here in variable info. All right. So there you have it. Your first super easy example. I changed some stuff, so I'm going to save that one more time. And now I know that's saved up to box. See, there it goes. Down there, saving up to box. And we're good to go.